Hello, my name is Sean Fisher. I've been a volunteer at the IEEE Club for the last 2.5 years, and I recently upgraded my home network. I've put together this little guide to show you how I did it. In Kelowna, the main choices for internet provider are Shaw or TELUS. Shaw provides coaxial, which they call Fiber Plus, and TELUS provides fiber optic. TELUS may claim to give you a dedicated line, but this is just a sales pitch. Only large businesses get dedicated lines. That said, anecdotally, it seems that TELUS offers better upload speeds, but slightly slower download speeds than Shaw Cable. But this may vary based on your neighborhood. This is not something that's going to be true everywhere. Both of these companies provide you with a gateway, which translates either the fiber optic coming in or the coaxial cable line coming in to Wi-Fi or Ethernet ports, which you propagate throughout your house. The gateway provided by your internet provider does not have Wi-Fi 6. It has Wi-Fi 5, and it also only has internal antennas. Aftermarket modems can provide external antennas with beamforming and also Wi-Fi 6, which can provide 4 times as many bits transmitted per symbol. My home network is connected to the wide area network through the Shaw Blue Curve gateway. The Blue Curve is connected to the TP-Link AX50 by Cat6 cable, and the TP-Link is connected to the 2 switches by a Cat6 cable as well. The TP-Link AX50 is acting in access point mode, which means the Shaw gateway is providing all of the local IPs to everything on the network, while the TP-Link AX50 is providing the Wi-Fi coverage. From the Shaw gateway's point of view, every device in my house is hooked up via Ethernet, since the connection to the AX50 is via Ethernet and the Wi-Fi link is to the AX50. The Shaw Blue Wave gateway has Wi-Fi that can transmit at 2.4 GHz and 5 GHz. As seen here, the 2.4 GHz band is severely limited in bandwidth. When I plugged the LAN cable into the laptop, I almost doubled my download speed. With the LAN cable plugged in, I have 1 millisecond ping times to both routers. When I unplug the LAN cable and use the Wi-Fi on the TP-Link, the ping time goes up considerably, especially for the Shaw gateway, which actually saw one packet have a 72 millisecond ping. To create your own wired home network, you will need a Wi-Fi 6 router. Make sure that it says AX on it instead of AC. Get some bulk Cat6 cable. Make sure that you do not buy copper-clad aluminum. It will say CCA on it, and it will be cheaper than full copper and will seem like a great deal, but it is not a good deal. The aluminum is covered in a thin layer of copper, and while the oxidation of the copper is conductive, the aluminum oxidation isn't. So when you cut the wire for the connector, it gets exposed and the oxidation builds up, and over time you start to have packet loss, and you have packet retransmissions, and you're unable to find the issue because it seems like there's a continuity seems fine, but you seem to have all of these losses, and it's a very hard problem to track down. The aluminum wire is also 40% more resistant per foot, so it's not really suitable for power over Ethernet as well, since a lot of the power is just wasted heating up the cables. And the aluminum is more brittle and less stress tolerant, so if you're yanking it through walls, it's going to stretch and break, and you will not see these problems. You put them through a cable tester and it will look like it is fine. So you will also need some connectors and strain reliefs. These are generally pretty cheap. Gigabit Ethernet unmanaged switches, you can get these for under $40. An RJ45 crimping tool. I picked one up that was 2/3 of the regular size, and it was, I think the whole kit was under $40. Some angle cutters. That's just to cut the plastic in the middle, as you'll see in the video coming up. And some optional things, you should probably think about getting some cable ties, also known as zap straps for cable management. You put the LAN cable in the zap strap, and then you staple the zap strap to the wall or to the roof or wherever you're putting it. Put the strain relief on first before stripping it, and then give yourself about 3 inches of slack so that when you strip the wire you have some extra. You can always cut it off a little bit at the end. Always use your fingers to pull it apart, never use the tool to rip insulation off. You see I have all 8 of the wires separated, and I fan it out, and I attempt to cut the plastic in the middle, which acts as a way to keep the wires apart to allow higher frequency transmission of the Cat6 standard. Unfortunately, these wires didn't come with the string, which is used to cut the insulation. It's not really a big deal, but most of them have a drawstring which you can pull down the wire so that if the insulation isn't down far enough, you can cut it further. As you see here, I'm unwinding the wires. You have to make sure that you do not stress the wires while doing it. They have a natural way that they want to be. So I carefully pull it apart, and then I start winding it back and forth. Careful not to cause any breakage of strands. I'm just trying to get these bumps out of the wire so that it's nice and straight. Do this first before we put it in any kind of order. Just kind of pull it along with my fingers and kind of wind it back and forth naturally to try and work out the bends. Now I'm going to start trying to put them together in the right order, because you have to have them all the same length when you cut them. So as you see, I put the colors together. It goes orange, white, orange, green, white, blue, blue, white, green, brown, white, brown. As you can see, I'm putting all of the wires between both of my fingers, and I'm wiggling it back and forth. It's to get the slack out of the wire and to fully extend it all the way out. Now, as you can see, obviously they're not going to be the same length as each other when you pull them out. So I'm just going to put them into the correct order and put them as close together as I can. So they need to go into the cutters. So now that I have them lined up, I can bring the cutters out. See, there's the cutting edge. And I want to make sure that they're lined up in the tool, nice and lined up right next to each other. I don't want them curved off, or else they're not going to be the same length. So we cut that, and as you can see, they're all the same length. It looks good. I take the connector and I put the tab down. So orange, white, orange, green, white, blue, blue, white, green, brown, white, brown. So I check it again here. Yes, it's all in the correct order. So I'm going to push the connector down as far as I can, because you don't want to have any unwound part, because the more unwound part you have, the more frequency issues that you have with the high frequency transmission. So I push it in, I push the strain relief up and over the tab, and I'm just showing you the wiring pattern here. The tab goes down on this crimper. So I feed it through between the blades with the tab down and into the crimper and make sure it's all the way in. Show you the cutting edge there. See? Okay. So now I'm going to cut it with my thumb. And since it's cheap crimpers, they're a little bit dull. I've used them a little bit. Use the tab, pull it out, have a look. It's in the right order, and it's full copper.